I'm Anil Kumar. Welcome to my series on integration. We are sharing with you questions from previous test papers. Let me thank all my students for sharing their test papers with me and doing fairly well in their exams. Now here we'll discuss question number 2 with you, where we'll learn the concepts of derivatives and integration. The question here is, the velocity v in meters per second of a particle moving in straight line is given by v of t equals to e to the power of 3t minus 2, where t is the time in seconds. Find the acceleration of the particle at t equals to 1. B. At what value of t does the particle have a velocity of 22.3 meters per second? Well, it is no calculator, so leave your answer as the exact value. Part C is find the distance traveled in the first second. So the very first part, we are given that the velocity v is equal to e to the power of 3t minus 2. We need to find the acceleration of the particle at t equals to 1. So what is acceleration? Well, acceleration is the derivative of velocity, right? So we'll find the derivative of this. So derivative of exponential function. So it'll be e to the power of 3t minus 2 times the derivative of the exponent, which is 3. So that's what you get, right? So 3 times this. Now if you need to find the acceleration at 1, t equals to 1, we'll substitute 1 here. So we get 3 times e to the power of 3 minus 1, which is 3, oh sorry, this is 3 minus 2, right? So we substitute 1, 3 times 1 is 3, 3 minus 2. So it gives us 3 to the power of 3 times e to the power of 1, which is 3, 3e. And so we get the acceleration at t equals to 1 as 3e meters per second square. Is that clear to you? Right? So that is how we are going to solve the very first one, part A. Now let's look into part B of this. It says, at what value of t does the particle have the velocity of 22.3? Well, we will now work with the velocity function as such. We have velocity as e to the power of 3t minus 2. We have been given velocity of 22.3. That should be equal to e to the power of 3t minus 2. To find the value of e, we can take natural log both sides, right? So we get ln 22.3 equals to ln e to the power of 3t minus 2, which is basically 3t minus 2, right? Since ln e is 1, so that is equals to ln 22.3. So from here, you can calculate what t is. So you get t as ln 22.3 plus 2 divided by 3, right? That is the value of t. So we'll leave it at this stage since we are not allowed the calculator, right? So time t in seconds is for us, let's write down here. So t basically is equal to 2 plus ln 22.3 divided by 3 in seconds. Okay. Let's take part C on a fresh page. Find the distance traveled in the first second. Now to find the distance traveled, we need to integrate, right? So we are given the velocity as equal to e to the power of 3t minus 2. Distance traveled in first second, that means from 0 to 1, correct? So that is what it means. So we need to integrate this, right? So the distance, it is a positive function, correct? So it is always increasing. Now since it is a positive function, the integral will also give you the area under the curve, which is the distance. So the distance will be integral of vt dt from 0 to 1. which basically is from 0 to 1. So the definite integral for e to the power of 3t minus 2. Now we'll apply the antiderivative rules to find the solution. So we get this as the function e to the power of 3t minus 2 divided by 3. And we are going to look into the limits from 0 to 1, right? So that is equal to 1/3 of e to the power of, when you put 3 here, you get 3 minus 2, minus, when you put 0 here, you get 1 over 3 e to the power of minus 2, right? So the answer here is 1 over 3 e minus e to the power of minus 2. Correct? So that becomes the solution, and the units will be in meters. So I hope that makes sense. So that is how we are going to find the total distance traveled in the first second. Perfect. So I hope this solution is absolutely clear. Feel free to make your comments and your suggestions and look into similar videos. Thanks for watching and all the best.